Fire feels like one of those things you don't question. It's there when you light a candle. It's there when you cook dinner. It's there when something goes very wrong. We grow up treating fire like a normal part of reality, almost boring, as if it's a thing, like water, like air. But here's the first strange truth. Fire isn't actually a thing at all. There is no substance called fire. And the moment you really let that sink in, the world starts to feel a little less stable. Let me ask you a simple question. Why doesn't wood burn all the time? Think about it. Your table might be made of wood. Your floor might be wood. Trees are wood. And all of it is surrounded by air. Air that contains oxygen, the exact ingredient fire needs. So why isn't your house constantly on fire? Why don't forests just burst into flames on warm days? Something about that should feel unsettling. We usually answer with phrases like, fire needs a spark. Fire needs heat. Fire needs fuel. But those are labels, not explanations. They don't tell you what's actually happening. They don't tell you what's stopping the fire and what suddenly lets it loose. Because here's the uncomfortable truth. The ingredients for fire are almost always already there. They're just waiting. Imagine two things that desperately want to be together. They're more stable together. They release energy when they unite. Nature prefers them that way. And yet, they remain apart for years, sometimes centuries, not because they don't want to react, but because they can't get started. Fire isn't about creating something new. Fire is about permission. Permission for atoms to finally do what they've wanted to do the entire time. When you strike a match, it feels like you're making fire, but you're not. You're barely nudging the universe. And once nudged, it doesn't respond politely. It runs away. This is why fire doesn't slowly fade into existence. It doesn't ease in. It doesn't warm up gradually. One moment, nothing is happening. The next moment, there's light, heat, motion, chaos. Fire doesn't ramp up. Fire snaps into reality. And here's what makes it even stranger. Nothing magical happens at the moment of ignition. No new laws of physics appear. No special fire energy is created. The only thing that changes is speed. Atoms start moving just fast enough for everything to suddenly fall apart, or more accurately, to fall together. Fire is what happens when a system finally stops holding itself back. And once you start seeing fire this way, it stops feeling comforting, because you realize something deeper. The world is full of things that want to happen, but are being delayed. Wood and oxygen are one of those things. Gasoline and air are another. Food and oxygen inside your body. Same story. Even you. Fire isn't an exception. It's a preview. And in the next part, we're going to zoom way in, down to atoms, energy barriers, and runaway reactions to understand why nature can be patient for centuries and then suddenly lose all restraint. All right? Now we have to zoom in, way in. Not with a microscope. That won't help. We need imagination. Because fire doesn't really live where we can see it. Fire lives down at the level of atoms. Picture this. Inside a piece of wood, there are carbon atoms. In the air around it, there are oxygen atoms. They're everywhere. They're bumping into each other constantly. Millions of collisions every second. And yet, nothing happens. No fire. No heat. No light. Why? Because atoms are a little picky. Carbon and oxygen want to be together. They're happier that way. They're more stable that way. But, and this is the key, they don't just politely drift into each other's arms. They have to get very close first. And getting close is hard. Here's the best way to think about it. Imagine a ball rolling on a flat surface. Nearby, there's a deep hole, a really deep hole. The hole represents a stable state. Once the ball falls in, it's stuck there happily. But between the ball and the hole, there's a hill. And the ball doesn't have enough energy to climb it. So it rolls around forever, right next to the hole, never falling in. That hill is called activation energy. Wood and oxygen are exactly like that ball. They're already near each other. They collide all the time. But at normal temperatures, the atoms just aren't moving fast enough to climb the hill. They hit, they bounce, they separate again and again And again, you could wait 1,000 years. Still nothing. This is why your table doesn't burst into flames. Not because it's safe, but because it's stuck. Now, here's where the match comes in. When you light a match, you're not creating fire. You're doing something much smaller. You're just making a few atoms move faster. That's it. Heat is not a substance. It's not a fluid. Heat is motion. The hotter something is, the faster its atoms are jiggling. So when you add heat, you're making atoms jiggle harder. And eventually, a few of them jiggle just fast enough to climb the hill. The moment that happens, everything changes. Because when carbon and oxygen finally snap together, they release energy, a lot of energy. That energy doesn't politely sit still. It turns into motion, more jiggling, and now something sneaky happens. The energy released by one reaction makes nearby atoms jiggle faster. Those atoms now have a better chance of climbing the hill too, so they react, and their reactions release even more energy, which speeds up even more atoms. This is where fire stops being calm physics and starts being a catastrophe. One reaction triggers two. Two trigger four. Four trigger eight. The number of reacting atoms doubles and doubles and doubles again, all in a fraction of a second. That's why fire doesn't ease into existence. It explodes into existence. Fire isn't gradual. Fire is exponential. By the time your eyes register a flame, billions of atoms are already snapping together, releasing energy, making light, making heat. It feels sudden because it is sudden. This is also why fire keeps going once it starts. The reactions create heat. The heat enables more reactions. The reactions create more heat. It's a feedback loop, a runaway process. Fire doesn't need encouragement. Once it's going, it encourages itself. So how do you stop it? You don't fight the fire. You break the loop. Cool it down. Atoms slow. Reactions stop. Remove oxygen. No snapping possible. Remove fuel. Nothing left to react. Take away one leg, and the whole thing collapses. Now here's the part that should really make you pause. Wood and oxygen want to react. They're not stable. They're not peaceful. They're waiting, held back by nothing but a small energetic hill. The universe is full of systems like this, things that want to release energy, but can't get started. Gasoline and air, explosives, food and oxygen in your cell, even stars. Everything is balanced on little hills, stable until it isn't. Fire just happens to be one of the few places where you can see that tension with your own eyes. Light and heat are the universe saying, okay, you pushed it. Now watch. And in the next part, we're going to follow that energy backward, because that energy didn't come from nowhere. It was borrowed, stored, hidden away for years, inside something you think you understand, a tree. Now let's ask a question that sounds simple. Where does a tree come from? Not where does it grow, we know that. You plant it in soil, you water it, it grows upward. So it must come from the ground, right? Except it doesn't. And this is one of the strangest misunderstandings in all of nature. Because if you actually do the experiment, and people have, the answer feels impossible. Here's the experiment. Take a pot of soil, weigh it carefully, plant a seed, water it, let a tree grow for years. Let it get tall, heavy, thick with wood. Then dig the tree up, shake off the dirt, and weigh the soil again. Almost the same. A tiny difference. A few minerals missing, but not hundreds of pounds. Yet the tree gained hundreds of pounds. So where did all that mass come from? The answer is unsettling. The tree came from the air. Trees are mostly made of carbon. And that carbon doesn't come from the ground. It comes from carbon dioxide, floating invisibly in the atmosphere. The tree inhales air, quietly, all day long. And from that thin, invisible gas, it builds bark, branches, leaves, roots, solid matter from empty space. The soil contributes almost nothing, just trace minerals, calcium, potassium, things like that. That's the ash you see when wood burns. That tiny pile left behind, that's the ground. Everything else, the wood, the mass, the fuel, came from the sky. Now here's where fire sneaks back into the story. because carbon dioxide is not easy to break apart. Carbon and oxygen love each other. They're tightly bound. Pulling them apart takes work, real work, energy. So how does a tree do it? How does it take carbon dioxide, already in its most comfortable state, and rip it apart? It cheats. It uses the sun. Sunlight slams into a leaf. That energy kicks oxygen away from carbon. The tree keeps the carbon, throws the oxygen back into the air, and uses the carbon to build itself. That's photosynthesis. Not magic, just energy doing work. Think about what that means. The sun is constantly pumping energy into Earth. Plants use that energy to push matter away from equilibrium, to build order from chaos, to separate things that want to be together. A tree is a collection of stolen sunlight, frozen photons. Every piece of wood is energy that once traveled 93 million miles through space, then got caught, stored, locked away in chemical bonds. Now remember what fire does. Fire takes carbon and oxygen and snaps them back together, releasing energy. So what is burning wood, really? It's photosynthesis running backward. The tree spent years using sunlight to pull carbon out of the air. Fire undoes that work in minutes. The carbon collapses back into oxygen. The stored energy pours out as heat and light. Fire is not creating energy. It's returning it. That flickering flame, that's sunlight. Old sunlight. Sunlight that fell on a leaf years ago, maybe decades ago. Now released all at once. When you burn a log in a fireplace, you're watching time unwind. Years of slow construction, undone in an evening. And notice something else. Fire needs oxygen. Where did all that oxygen come from? From plants. For billions of years, plants have been dumping oxygen into the atmosphere as waste. They don't want it. They throw it away. Early Earth had almost no oxygen. The air was poisonous to fire. Then life changed the planet. Plants filled the sky with fuel. They made fire possible. So fire isn't a fundamental force. It's a side effect of life. No plants, no oxygen, no fire, which means every flame you've ever seen owes its existence to leaves. And now we're standing in a strange loop. The sun powers plants. Plants build structure. Fire destroys structure. The energy returns to heat and light. Nothing is created. Nothing is lost, just rearranged. In the next part, we're going to close the loop, because there's one last place this reaction happens, inside you. Now let's close the loop, because fire doesn't just happen in fireplaces and forests. It's happening inside you, right now. Every time you breathe in oxygen, you're feeding a reaction. Every time you eat food, you're supplying fuel. Inside your cells, carbon-based molecules meet oxygen. They combine. Energy is released. That process is called respiration. But chemically, it's the same reaction as fire. The only difference is control. Fire burns everything at once. Your body burns things slowly, carefully, step by step. Fire releases energy as heat and light. Your cells capture it in tiny packets, store it in molecules, and spend it on thought, motion, memory, life. You are not powered by food. You are powered by sunlight, delayed, recycled, released slowly enough to keep you alive. The sugar you eat was built by plants. Plants built it using sunlight. That sunlight traveled across space, hit a leaf, got trapped and waited, then you ate it. And now, inside you, that energy is being released quietly, patiently. You don't glow when you burn, but make no mistake, you are burning. This is why you get warm when you run. This is why your body temperature stays high. This is why you need oxygen every few minutes. Stop the oxygen, and the fire goes out. Seen this way, life stops looking like something separate from physics. Life is not a violation of thermodynamics. Life is a clever way of obeying it. The universe wants to spread energy out. It wants gradients to flatten. It wants differences to disappear. Life doesn't fight that. Life accelerates it, but in a structured way. Plants gather energy slowly. Animals release it slowly. Fire releases it fast. Different speeds, same direction. And this brings us back to that strange idea we started with. Fire is not a thing. It's a process. So is life. So are you. You are not a static object moving through time. You are a controlled collapse, a temporary arrangement of atoms that only exists because energy is flowing through it. The moment that flow stops, the arrangement falls apart. Just like a flame, this can feel unsettling because it means permanence is an illusion. Stability is conditional. Everything is metastable, balanced on a hill. But it can also feel beautiful because it means you are not separate from the universe. You are something the universe is doing. The same sunlight that powers stars, that powers trees. The same chemistry that lights a match keeps you alive. The same laws that tear structures down also build them up. Fire looks destructive, but fire is just energy returning home. Life is energy taking the scenic route. And one day, the reactions will stop. The fire will go out. The atoms will settle into quieter arrangements. But nothing is lost. The energy keeps moving. Always. So the next time you see a flame, don't just see danger. See history. See sunlight from years ago escaping. See matter remembering where it came from. Fire isn't destroying the world. It's reminding the universe how it works. And so are you.